All right, hello everyone. My name is Mildred, and this is batch C of Backend development with Python and MySQL. In today's class, we are going to look at functions in Python. Then we're going to look at how we can use nested functions and closures in Python. We have looked at, in the pre-recorded video, we looked at functions in very basic form. And now we want to look further and deeper at functions in such a way that we can use them to write production-ready code. Now, in Python, we define a function using the def keyword like this. And when we write a def keyword, we now write a name we want for the function. It is always good for you to give descriptive names to your function. The names of your function can be any name you want, but just make sure that the name is descriptive as good programming practice. Let's say I want to create a function called greet, for instance. I want the function to be able to display the statement hello world to the users, or when this function is called. Now I name the function greet, which is just going to do that. Greet, say hello world, or you want hello and welcome. We call a function by writing the function name greet like this, and once we do that, it is going to print out what we want it to print. Because we use a print statement here, we don't need to print here. When we run this, it is going to print hello world here for us to see. But most of the time when we create a function, or all the time, what we want to do is to use a return statement. A return statement just signifies the end of the function and returns an output or whatever is supposed to return to the calling program. And so instead of print, what we do is say return. So we use print when we're just testing. So we return hello world. And so when you want to see or test the function, you put it in the print statement like this, print greet. And then it's going to print out what the return value of the function is, which is hello world. Okay? This function that I just created, we can call a void function. In the parentheses of the function, there is no argument. So you just call the function with the parentheses. But then there are functions that take something we call parameters, that is values within these parentheses. And when we have parameters, when we call this function, we need to call these functions with arguments. Now there are different types of arguments. We're going to look at them. But first of all, let's look at a function that will take that is defined with a parameter, and then we'll call the function with an argument. So parameters and arguments, sometimes people use them interchangeably, but what I understand is that a parameter is what you call it when you are creating the function, when it is in the function definition, and then you call it an argument when you call the function and you're supplying values. Okay, so let's say, for instance, we want to create one that will take argument. So we're going to define this function with parameter. We want a function that, let's say let's use a popular one, calculate the area of a circle. And the formula for this is pi times radius square. So we have a module in Python which is called the math module, and we just import that module. I don't think you've got into the Python modules topic, but just know that when you have another Python file somewhere, or maybe it's inbuilt Python library, when you want to include that file, or you want to use functions and methods from that file on a different file, you use the import statement like this. So there is a module in Python called the math that holds mathematical formulas and values and constants. And so we want to just use the value of pi from the math module, or we can just decide not to do that since we've not done that topic, but we're doing things to standard. But we're going to review this back, and we're going to use import statements when we get to the topic modules. So we want to define the area of a circle. We want a function that every time we call this function, it gives us the area of a circle when we supply the value for the radius. So let's say def area circle like this, and we'll supply radius. Let's say R. And then in the body of the definition, we want to say what it will do. So we want this to return the value pi times R square. Now, pi value is 3.14 times the radius raised to the power of 2. Okay? So this is the formula, and we plug in the value and we say this is what it should return. And when we come here to say we want to get the area of a circle, now we know when the radius of a circle is 20, the area will be 1256, I think. And so let's try that to see if we call this and say print area circle, and we supply the value of the radius to be 20. This is called supplying the argument. Now it is a parameter, R is a parameter, 20 is the argument we have supplied as now the value for that parameter. So when we run that, we should get the value 1526 here printed here, and because this is the area of a circle whose radius is 20. You can do this for all mathematical formulas. So if you see you have a project where you want to design a scientific calculator or something, you can now use functions to create different functions for the different calculations. So if you want to get for cosine and sine and all that, you research what the formulas are, look at the math module if you have constants that defines the value of all of these things, and then you create functions that when called is going to calculate this and wants the argument. So the values the user presses on the calculator will now be the argument. Now, while on the topic of arguments, let us look at the types of arguments that we have. Now, when you have arguments that are more than one, for instance, let's say we have, let's use another one that we can have more than one argument, not just the radius. So let's say, for instance, we want to get the area of a trapezoid, for instance, and the formula is A plus B. And when we say A plus B, we just mean that we're calculating the top base plus the bottom base, and then divided by 2 times the height. I think that should be the formula. Let's write it there so we can understand that. So let's say for the area of a trapezoid, which we want to do, I think it is, we have the top base, we have the bottom base divided by 2 times height. This is the formula. So we're dividing this by 2, and then we are multiplying it by the height. So just separate it like this so that we can know what we're doing. All right. So this is how we calculate the area of a trapezoid. We want to create a function now, because now we are having 3 different parameters we want to define. And we want to see how we call a function that has more than one parameter. So let's create a function. Let's say the name is area of trapezoid like this, and we want to supply the arguments A, B, and H. And then we want to tell it to return A plus B over 2 times H. So you see how creating a function can be easy. You can get complex at some points, but it's easy for you to just think about what is this function going to do? What value is it supposed to return? And then you define the function by creating a name. In the parentheses, you decide if it's a function that takes parameters and is going to do something with these parameters. So, and when you call the function, you supply arguments that replaces these parameters and does the computation and returns the value. So we want to return the area of a trapezoid once the top and the bottom base and the height is supplied by the user. So every time somebody is calculating an area of a trapezoid, and let's say you have a calculator that calculates the area of a trapezoid, you don't know in advance what values the users are going to want to calculate for the basis and the height. So when you have a function like this, every time they punch the values, it runs the function to give them the total from it. Okay, and so we have this like this, and what we want to do now is to, let's say we want to say x is equal to area trapezoid, and we supply values to this. So let's say we want to supply the value of let's use 235, one base, top base, bottom base, and the height, like this. And when we calculate this, we're expecting that we'll get a value of 12.5 for the area of the trapezoid, whose top base is 2, bottom base is 3, and the height is 5. And so when we say print x, we can come here, run this, and we have 12.5 as the value, which is correct. So we now have a function that does this over and over again. And so when you write your programs and when you're designing the back end of your project, there are certain things that will be called all the time, and you want to just use a function. And once you have a function for it, you can reuse your functions across different programs. For instance, you have a sign up page. You want a function to be called whenever the user clicks sign up now or something, and that function is going to take as its argument the username and the password or the email and all the things on that form, and then it's going to supply that as an argument to the register function, and then when you call the function, it saves this in the database. The same thing when they want to log in, you want it to call a login function that will take as arguments the username and password the person has entered and verifies this against the values in the database, and then redirects the user to the home page of all authorized users if the credentials are correct, and if not, redirects to another error page. Okay, anybody has questions before I talk about the types of arguments that we have? Is it understandable?
Yes, please. It is.
Okay. All right, so when we have arguments like this, these are called positional arguments. And when we say positional arguments, what we mean is that the arguments must be listed in the order in which the parameters are defined. We define the top base, the bottom base, and the height in the function definition. That is exactly the order in which we must specify the argument. So those are positional arguments. We have something we call keyword arguments, which is what you will use most of the time in production ready codes, because keyword arguments are like name. Every argument has a name. So at this point, you just use the name, and it does not matter the order in which you specify the values. So let's give an example of this. Now, all what we've done so far is called positional arguments. If I decide to put this in any order, it's going to change the value, because if I say the height is 5 and I put the height here and the top base is 2, I put it here, this answer is going to change. It's not going to be correct anymore, because now it's expecting it in the same order in which the parameters have been defined, and I put it in any order here, and it will assume that the top base is 5, not the height is 5. So now, how do we solve a problem like this? When we want to solve this kind of problem, we can say, for instance, I have defined this ABH. So I can now decide to say H is equal to 5 here. I can now say B is equal to 3 and A is equal to 2. Now this will solve the problem, and instead of printing 8.0, it will print the correct answer of 12.5 back here, because what we have used now are keyword arguments. We put a name that the value is referring to, which is preferably the name of the parameter. When you have functions, sometimes you have documentations of the function definitions and the definition of the parameters, and then you always know what is expected as the values, what you're supposed to supply as the values for the arguments whenever you use functions, especially when you use functions that you did not create. You're using the functions from a library. So you can have your own library of functions depending on the applications that you're creating. You might want to create an application and you're not using a framework. You have your own definitions and functions that you have created for this application to work. And so at some point, and that's what brought about most of these libraries that we have, that we sometimes use and say that there's a particular library that can help you to book appointments. And so because somebody who has created it released all of their code as a library, and other people clone these projects and use them instead of reinventing the wheel. So you want to try to think about different kind of functionalities you want and try to make that functionality a function, and when that function is called, you want it to do something. Okay. Another thing which is not in the scope of this particular class is return types. When you write code for production, you will need to specify the return types. And when we say return type is, like we specify this now, the values, you want to put the expected data type of all of this. So let's say this is a float, for instance, and we want this to be a float, for instance, and the height also to be a float. And then we also want the final value, the answer, to be float. This is how you specify return types, and this is what you see most of the time, or even all of the time, when you find production ready code. It's going to have types here. And we have a module in Python called the typing module that supports type hints, and at some point we will look at this maybe in course 3, in a higher course than this, the production development, because you will see how we use the typing module and how we import all of these different types and do type hinting when we create our functions. Okay, so know that you can write the parameter, a column, and the expected data type. There can be an int if you want, and so when you go through some checks, if there's a standard the code must keep to, and you go through those checks, it's going to check for all of these things and ensure that this is what it's returning, and this gives you a more professional code. And when you work in teams, you will know what is expected of, like the standard everybody's code should keep to, and that way it will be uniform across teams. Okay, now we have something called higher order functions. And a higher order function is a function that contains other function as its parameter, or it returns a function as an output. Now, it doesn't make sense when I say it, but it might make sense when I do it. So let's try it out. Let's say we want to get let's say I want to create two functions, for instance. One is the area of the trapezoid, and the other is the perimeter of a parallelogram. These two functions have formulas that includes addition of two of the values. Let's see what the formulas are. The formula for getting the area of a trapezoid, let's write it. We have it there already for the first time. The formula here is a plus b over 2 times height. The formula for getting the perimeter of a parallelogram is 2 times side plus base, and so we represent the side plus base as a and b. Now this has an addition here, and this has addition here. We can do this using something we call higher order function, where we can have a function that takes a function as its argument. And let's do that. Let's see. So the first thing we want to see is something is in common here, something that adds both. We want to first create a function that will add two numbers. So let's say def some num, let's do some num, and then this will be a plus b. So if we want to use type hinting here, we can put a is an int, b is an int, return an int type. You can still return floats, like the value of the return value, You can say you want it to be float, or let's say here is float and float. So sometimes it's safer to use float because some of these values supplied can lead to, especially for the ones that have divisions, can have floats. But this is integer, so let's just use float, and we return a plus b. So we have this function. We want to now have the area of a trapezoid that we did here. I'll copy this. Now look at how we defined the area of a trapezoid here. We said return a plus b over 2 times h. And now this is not how we want to do it. We supplied, or we have parameters a, b, h, and this is not what we want to have. We want to have a parameter now that is a function. We created a function that will add 2 numbers. We want that function to now be a parameter here. And so we'll say, let's represent the function with func like this, and then we want it to take the value for the trapezoid. We'll say the value is a plus b over 2. So, and we need the value of height then. So we'll say func and height. Now, how does this work here? So we've supplied this function as that, and what the formula says is a plus b over 2 times height. So what we are going to return, because the function represents a plus b, so we'll say return func over 2 times h, like that. So we've done the same thing, only that we made this a higher order function. Is it understandable or confusing? Does everybody understand?
Yes.
Yes, it's clear for me.
Okay. So we make the parameter the function that does one thing. This function returns a plus b. So this is a higher order function. Now we already have this function here. We want to use it for the perimeter of a parallelogram. So now, because a plus b is here, so what we'll do is apply function has the parameter, and it will be 2 times func here. So let's do that. Def perimeter parallelogram, and we'll say 2 times a plus b. This is what we would have done without the higher order function, but we want to change it now, and we want a and b, so which means the only arguments that this will have, or is going to be the function. So we'll say func, and then we return 2 times func. So the function, when called, when you supply the function here. So let's try to do an example to supply argument. So when I say print here some num, I'm not going to use some num. So let's do area of a trapezoid. So let's say print area trapezoid, and we supply the value for the function. Now the trapezoid has the function, and we call that function some num, right? That's what we are supplying. Func is a placeholder for the parameter, so we have to supply a function. The function that we have to supply as an argument is some num. So we'll say area trapezoid. In the parentheses of that, we'll say some num, and we want to supply the value, let's say 2 and 3, and then we want to supply the height of, let's say 5. So we'll see that we want to use the same we use here to see that we'll get the same value of 12.5 here, only that we use a different method. And for parallelogram, we just want to supply the values for the sum num 5 and 7, and then this is going to multiply it by 2 automatically like this. So let's say we supply 5 and 7, or 2 and 3. So the expected value, if you use a calculator for this, is that on the first one we want to get 12.5, and on this one we want to get 24. If you use a calculator to make the calculation. So let's try this and see what we get. So we have 12.5 and we have 24, but you get the point of what a higher order function is. So a higher order function takes a function as its parameter, or it returns a function as an output. Any question? There's something also that is not contained in your pre-recorded video, args and keyword args, and this is also something that we use a lot in part 3. Args are just like, let me alternate all of this now. It's like when we have a convention of what we name things, args. Args is just like the arguments, and keyword args is just like keyword argument. And I'll tell you what these two special symbols are. Args is represented with an asterisk, and keyword arg with double asterisk. Okay, now args is a wildcard character that we use in front of a name, any name we want. And when we use this is when we do not know in advance the number of arguments that the user will supply. For instance, you have an application. Well, okay, let's say a very popular application that too many people, millions of people will use in a day. Let's use an immigration site. People apply for visas and they have the option of applying for single person visa or for group visas for a family or something. Now, the people who created these apps or these websites for those immigration departments will not know in advance how many family members each person who is going to apply, or millions of people that will apply, will supply. And so they have a function that use something we call args that will help to allow any number of arguments or different number of arguments from different people and will still work as expected. Now, let's create a function and let's say this is called group application, for instance, and we want to have parameters. The parameter we want to have, we do not know in advance the number of arguments that they will supply. So in the group application, you want to have like the family name, and then you want to have the first names of everybody there. So maybe you say the father is the primary applicant and fill in the mother's name, the children's name, and we assume that they all have the same last name, right? So we don't know in advance how many arguments that user will be supplying. So we can say something like we have the first argument, so name it arg1, for instance, and then we'll have the second argument, which will be the last name. Or instead of arg1, let's just say first name. Or let's say family name. So the first argument is family name. We don't know in advance how many people in the family. So let's just put it like names as the argument here. So when we have this one asterisk preceding the name of a parameter, this is the args that we're talking about. This is going to tell us that the user can specify the family name as the first argument and then any number of names for the family names, or sorry, for the names of each member of the family. Okay, so we can do something like this. Let's return. Let's use the format string to just write a statement. So let's return the members of the last name family are. We're going to join all of each of the name that are here. So let's run this and see if this is correct. Sorry, we didn't print that, so let's call the function group app, and then we'll put the first argument here is the family name, and these are the members of the family. And so when I run this, we have Let me print it first. Because what we are doing here is return, so we need to print to get something displayed here. So when I run this, we should have the members of the Smith family are John, Jane, Alice, and Bob. So this return statement just tells us the family name and the members of the family here, because we use keyword arguments. It will supply something else like here. So this, for this family now, they have John, Jane, Alice, and Bob. Let's say we have another family here that have, let's say, the Johnson's family, and we have 10 members of this family. So let's have Tom, Jerry, Mickey, Minnie, Charlie, Daisy. So this one has more members than the other one. So when we print, we'll see that no matter the number of the members of the family, it will take endless numbers. So this function now will now work for everybody without us having to know the number of people in that family. Is it clear?
Yes, it is.
Okay. So in summary, what you do when you want a user to supply arguments and you don't know in advance the number of arguments the user will supply, you put an asterisk in front of the parameter name in the function definition. Also, if you don't know in advance the number of keyword arguments that the user will supply, you use double asterisk. Yeah, we know what keyword arguments are. When your arguments, you supply them with a name, like A is equal to something. That's the keyword argument. So let's say let me comment this out and let's try to do keyword argument. So let's say we have let's do the same thing, group app for instance, and this is just keyword arguments we'll supply, and we'll just say family, and then what we want to return here. So the members of family name are this. So we return something similar, but now we're using keyword arguments. We don't know in advance the number of keyword arguments that the user will supply. So let's say we want to now write this. Let's call this. So say group app, and we supply keyword arguments now and not arguments. So it has to have a name. So say group app here, let's say family name Johnson, and then I'll put names Daisy, and maybe I'll put something like age, that, and then this one will have just family name and names. Let's see if this example will work. I'm trying to get an example that makes sense, and I will have ages here on the second one. Okay, so we are having keyword arguments now, not just arguments. It's similar to the other one, it's just that these arguments are named. So let's try this and see if it returns the desired that we want to illustrate. So we have the members of the Johnson's family are Tom, Jerry, Mickey, Minnie, Charlie, Daisy. Here the member of the Smith family are Tom, Jerry, Mickey, Minnie, Charlie, Daisy. Here we do not say anything about their ages here, but we supplied it as the argument. Let's add ages to this. We'll say their ages, and we'll join. We use for I, we use a loop so that we can put the age for each of this person to come for the age. Okay, let's see if this will work. Even though this doesn't look like a good example of what I want to illustrate, but let's try it here. It's not a good example, this key error age here, for the second one. But for the first one, it's going to print it out because I try to join it like this. So let's see what is going to, an example that will make more sense here. We can do to get like the number of keyword arguments. So let's say number of keyword arguments, and then we'll say we want to get not this one. So let's say print let's return here return family. Let's say we're going to be returning family like that. We don't know the number here. Let's print group app family here. I want to illustrate something. I'm trying to get the best example to see what will work. So say father John, mother Jane, son Jack, daughter Jill. Let's see if this works as the kind of example I want to illustrate. And then this one will have pets and doesn't have father with it. So what I've done here is we just want to return what is entered as the keyword argument. So it probably illustrates what the definition of this is. And so when I run this, I'll get the father John, mother Jane, son Jack, daughter Jill. The second one added the pets to it. You can have as many number of keyword arguments as possible like this, and it will print them out without any errors because we don't know in advance the number of keyword arguments the user will supply, and so we have double asterisk. And one of such real life scenario application of this is when we get to databases, and let's say for instance we want to have a function that inserts records into a database table. At this point, that insert function, we want to use it across different tables, and different tables have different definitions. We have different column names or number of columns for each of the different tables. And so when we call the insert functions for table 1 that has 20 columns defined, and we call the insert functions for table 2 that has 2 columns defined, we want it to work to do this. And so that's where keyword arguments will come in, because when we supply the column names as this to send the data in a database, then that is one real life application that I can tell you about, the keyword arguments. There are many applications, but mostly when you are doing your database transactions. Anybody with question? Do you guys understand this?
Yeah.
Okay.
On my end.
Yes, I do.
Yeah, so I want to ask a question.
Okay.
Because I've seen an example that has, instead of the word family, it has the keyword arg as the parameter. So it doesn't matter the word we use as long as the double asterisk is there in the parameter.
Yes, it doesn't matter what word you use. Some people, like in programming, most of the time what you see is keyword arg. You won't see family. You'll see keyword args like this. That's what they'll put.
Yeah.
So that's what they put. So whatever the name is, the double asterisk is what is important, and it's still going to do exactly the same thing of printing what we want out. Okay.
Okay.
So when we define functions, sometimes we can have default parameter values, like we can have the default value for it. Let's say, for instance, we are also creating, I want to think of a real world application that will make sense. Let's say we're creating an application that has, let's say, social security benefits, or for countries that use treasury, and you go and collect some government benefits. If we want to ask them to fill a form online, and we want to ask them to fill in their country of birth, for instance, majority of the times for people to claim those benefits, they have to be citizens of that country. So we want to put, and sometimes they are not citizens, they're just working on a work permit or something, but the majority are citizens, and you want to reduce the time it takes to fill forms for people. And now what you would now do in this case is to have default parameter values, so that they can skip entering that, and it will insert the current country as their country of origin, or their country of birth. Let's do an example of this. Let's say let's call this benefits, for instance, and we have a parameter called country. Let's call the country parameter. Now, because we know that most of the people that will fill this form are from that country, have to be residents or citizens of that country, we want to just put that country name as a default value. Let's say, for instance, we'll put this as USA. Okay, we'll put this as USA, and what we want to do here is to say return we'll return these statements to insert the country. We just want to return any statement we'll make that will return the name of the country. Now, when you call the function, let's say I want to print benefits Canada, it will print Canada. I want to print benefits without having anything there. I don't supply value for the I don't supply argument for the function. I can call it empty, or I can call it with a country name. Now, the country is different for me. It is not optional. I have to fill it in. I'll say the benefits of living in Canada here, because I filled Canada the first time. The second time I didn't fill anything. It uses a default value. The benefits of living in USA are this. So when you design your applications and you begin to put those optional fields, or you say fill this field for those who were born outside of the country, select your country. So those who are not born outside of it, that is not applicable. So automatically you want it at the back end to insert the country as their country of origin. Now, is it understandable?
Yes, miss.
Okay, so in summary, if you have a default parameter value there, it means that you can call the function without supplying arguments, or you call the function to supply an argument to change the default value to the value that you supplied in your argument. Okay, when you define functions, you see sometimes I have a red wriggly line, and I'm just trying to create just a skeletal page. But anytime you create a function like this, you're going to have this red wriggling line to say that, or everything in red to say that this is going to error out. But because it's a placeholder I'm creating, I'll decide what will be in the body of the function later. We use something called pass as placeholder. So you can define things like this, right? Pass means just don't error out, do nothing, but you just call the definition like that. Okay? So when you function definitions cannot be empty, and if they are empty, they will generate errors, and this is the only way you can have a placeholder. And you write pass to have a placeholder. If you want to come back later to define what the function will do. Okay? when we have functions and we want to use positional arguments, we don't want to allow keyword arguments when people supply values to these functions. We add a forward slash after we define the parameters. Like, let's say def let's say their full name, for instance. And we do not want the person to use keyword arguments. So full name is going to be first name. We want them to supply middle name, and we want them to supply last name, right? And we don't want this person to be able to use keyword arguments. We'll just put a forward slash at the end like this. And then when we say return, let's return this like this. So when we say print, we want it to be positional only. So we're printing full name, and we're supplying John Doe Smith. Let's clear and see. So we have John Doe Smith here. But if we decide that we want to say full name, last name is equal to John, it will error out because it only allows positional arguments and does not allow keyword arguments. So you see, for Visual Studio Code, we are getting this wriggly line already telling us there's an error. So let's put here, let's put middle name, or let's put first name equal to, and we put middle name is equal to. So now we've done this. So this that we have done, let's try this and see. We cannot mix positional and keyword arguments. We put the forward slash here. When we run this, we get an error, and it says got some positional only arguments passed as keyword arguments. So these arguments must be positional only when we pass them, and we pass them as keyword arguments. We'll get error because we say it should not allow. If we want to allow only keyword arguments and no positional arguments, I think we add in the asterisk sign. You see at the beginning, let's put the asterisk at the beginning here, and it then means that this should take only keyword arguments and no positional arguments. Let me clear and see. It's either at the beginning. So when we run, it prints Doe John Smith there, but when we try to remove the keyword, then we begin to have problems. When we run this time, we have an error saying it takes 0 positional arguments and 3 are given. All we want is keyword argument. So you can actually write your code so that you can allow positional arguments for some particular arguments and keyword arguments for some of the arguments. So you can add an asterisk before the arguments that you want to be keyword only, and forward slash after those you want to be positional only. I think that's how it is done. So we can say if we put, let's add something here to make it longer so we can know how to mix both of them. Let's say age, weight, like this. And let's say we want to say any argument that we want to be positional only, like we want first name, middle name. We want this to be positional only. We put a forward slash here. So all the arguments before this forward slash will be positional only. Now, all the arguments that we want to be keyword only, before the argument, we put an asterisk like this. So everything after the asterisk will be keyword only. Let's try this and let's see whether this is correct. Okay, so we put them in a statement and we want to print. So we say any argument before the forward slash are positional only. We have to just write the argument like that. Any of the parameters that are before the forward slash, the arguments will be positional only, and after the asterisk is keyword only. And so we did the first one correctly. Let's run that and then do the second one wrongly and see. So run this, everything is fine. John Doe Smith is 30 years old and weighs 200 pounds. Now let's change this to say first name is equal to John, last name is equal to Doe. I will not put a keyword argument here. I will not put a keyword argument here. And I will not put a keyword argument here. You'll see I'll get errors because these are keyword only and I use positional. So we already have a wriggly line that tells us that this is wrong. So when I run, we still have it there to say positional argument follows keyword argument here, and we have this error showing up here. Okay? Do you understand it?
Yes.
All right, we have functions. Sometimes we can have a function within a function, and we call these nested functions. A function that is defined inside another function is called a nested function. And let's think of a use case of this nested function. If you want to provide encapsulation and hide the function from external access, you can use nested function. And let's do an example. I'm trying to think of an example that will illustrate this properly. But for us to illustrate it properly, nested functions, let's look at the concept of closure, and then we'll be able to understand this properly. A closure is a function that retains access to variables from the outer scope, and even after the function has finished its execution. And we know that scope of a function is when we define a variable. Let's say here we say x equal to 5 within a function. Only within this function call does Python interpreter knows the value of x. Once the function returns a statement, the value of x is forgotten outside of this function definition. But when you put this x equal to 5 outside of the function definition, it is global in scope, and then anytime you call it throughout this file, it knows the value of x. But when it's inside the function, it only knows its value when you call that function, and when the function finishes executing, it does not remember the value. When we use closure, it retains access to the variables from the outer scope even after the function has finished executing. Let's say we want to have a function, nested function, and this nested function is nested function that takes an argument, right, in its outer function, and then in the inner function takes another argument, and now adds the argument of the outer function to that of the inner function and returns the inner function. Okay, it returns the sum of them from the inner function, and from the outer function returns the inner function. Let's do it like this. Let's say def add num. We've done that before, but this time we'll put x here, and we want to have, this is the outer function, we want to have an inner function. We'll say def, let's say inner function, and this will take y. We want this inner function when called to return x plus y, and we want the final to return the inner function. So the outer function is returning the inner function, but the inner function returns the sum of the argument here. So it retains the value. This is how we look at the concept of closure, that it remembers the value even outside the scope of this, the inner one. So you see the inner function is encapsulated by the outer function. When we get deeply into production development, then we begin to see why this is important and some real life use cases that will make better sense. So when we do this and we want to create a closure now, so this example now, what happens is that the add num outer function takes a variable, adds it to the return value of the inner function, and then creates a new, this will create a new closure at the time it is called. Now this inner function now will capture this value, the value of x, and it will allow us to create a new function on the fly every time. Whenever you have a closure, you can create new functions on the fly. For instance, let's say I want to create a new function called closure1, and closure1 is equal to add num and supply one argument 5. So because add num returns the inner function, we have created a new function on the fly called closure1. Now when I want to print the value, I can say result is equal to closure110. What does this mean? This is the function I've created on the fly. So this is like I've worked with the outer function. Now it returns me the inner function, and I'm going to work with the inner function now. And so it's going to add 10 plus 5. We expect that when we print results, we should get 15. And we'll have 15 printed. So when you want to create functions on the fly, you have the outer function that returns the inner function, and then you supply arguments according to what the inner function is, and then you supply that argument when you call the function you created by executing the outer function, and supply that there. Do you understand?
It's not very clear.
Okay. So let's look at the function of the collecting user input before we end today's class. When we look at user inputs, let's look at error handling one time, so that when you get to that topic, we won't need to discuss that. We collect input from users. So when we have a form, the form's purpose is to collect input from users, right? In Python, when we say we want to collect input from user, we have an input function that we use like this, input, to collect user input. Okay? How do we use this function? We say user input equals to enter family name. When you run this function, when you run this stuff, and it asks you for enter your family name, and you enter the name, what do you want to do with the inputs that the user has entered? Let's look at an example. I've done this in a previous class before. Let's look at error handling, and let's try to collect information from the user. The user enters this information, we want to do something with it. So we have, in Python, we have two types of errors. We have syntax error. Now, if you have looked carefully at the error messages we've been getting, some of them are syntax error that occurs, and some of them are logical errors or exceptions. Now, syntax error occurs when there's a mistake in the code that prevents it from running. For instance, when we don't indent it, when we do something that the code is just wrong, there is a syntax error. So when we have an indentation error, we don't indent, it's a syntax error. But when we have a logical error exception, it has passed the syntax test. It happens at runtime. So for instance, if I say 10 divided by 0, the syntax is correct, everything. When I run, I get a logical error or exception. That's a runtime error. Those are logical errors. So in Python, when we want to handle these errors, we don't want it to just print these errors on the screen for us to see. Sometimes we can't understand it, we can't read it, and if we build an application and we don't handle errors, then the users will not know what it's talking about, what they need to do to make it right. So if, for instance, you go to the ATM to withdraw money, and you put your card and you type in an amount, and the card ejects, it tells you nothing because there's no error handling. You will not know what to do that you'll get your cash. you just be lost and say it keeps rejecting my card because there's no error message. But sometimes you put in something and you type there and say maybe hardware malfunction, or it will tell you something like you've exceeded the daily withdrawal limit or something like that. Then you know exactly what you can reduce the amount you are trying to withdraw. So those kind of error handling. So let's try one here. Let's try to implement simulate like an ATM machine, and let's say we want to look at this error in Python. Any code that might result in an error that might fail, you put them within something we call a try block, like this. What we want to do when that code fails, we put in the except block, like this. And what we want to do, regardless of what happens in the try except block, we want to put in the finally block, like that. So we'll pass. So I do this, and then we're going to say what we want to do. Sorry, hold on. So in the try block, we want to write a code. Let's say we want to collect information. And this information we're trying to collect, let's say we want to store the amount that the user enters. We want to tell the user to enter an amount. Okay? So let's do this. I will say amount is equal to user input, or let's say amount is equal to input, and I'll say enter an amount. So it will prompt for the user to enter an amount. When this amount is entered, it's always going to be of the data type string. For us to be able to compare this with the daily maximum amount that the person can withdraw, or the maximum amounts that can come out in one transaction, we need to convert it either to an int or a float, depending on what it is. So we're going to convert this to an int. So we're going to cast it to an int, and we'll say if amount, or if int amount, because the amount, when the user enters the value, even if the user enters numbers, the input function will return it as a string. So if this amount is greater than, let's say 1000, we want to do something. We want to say let's print to the user, print you must enter an amount less than 1000. You must enter an amount less than, or let's say an amount not greater than 1000. Okay, then that's what you want to display on the screen. We'll say else we want to do something. We want to say the amount is amount, and print like take your cash. Thank you for the print take your cash. And then if any error arises here, we want to do something for the error. Let's say the person enters a string of characters instead of the amount. We want to say invalid input, please enter a number. So things like this, print invalid input. And then if the person gets invalid input and injects their card and doesn't bother to continue the transaction, regardless of what happens within the try and accept block, we want to print out thank you for using this ATM, something like that. Okay, so this is just to simulate a process that we want to use to illustrate that we are trying to collect user input. We want to use this input to do something, and while doing that, we want to handle errors. Let's even see if this is going to do what we expect, else we adjust our code. We might look at the error handling topic again later so that we can look at it in deeper details, but I'm using this to illustrate user input for you to get a hang of how it is used in a better scenario. So when I run this, I have enter an amount, let's say 1,000, and it say the amount is 1,000, take your cash, and thank you for banking, for using this ATM. I'll run this again and supply an amount greater than 1,000. I'll say 3,000, and then it will tell me you must enter an amount not greater than 1,000. Thank you for banking with us. So it's doing what I want it to do. Let me enter my name instead of an amount. Enter an amount, and I put my name, and now I have to get an error that say invalid input. It will raise an exception saying invalid input. Thank you for using this ATM. So what we've done here is that we've tried to use all our code within the try block, and then the except block, what happens when something goes wrong in the try block, and in the finally block, what the system should just do regardless of what happens between the try and the except block. Okay? Is there any question? These are all the topics we intend to cover today, and I think this is the end of the presentation. So let me know if you have any questions. Does everybody understand?
Okay, I do, but the only aspect that wasn't very clear for me is the nested function.
Okay. You want me to repeat that?
Yes, please.
Okay. So let's look at nested function again. It's a little tricky. Nested function, you have to practice with it for a little number of time for you to make a little more sense. When we have a function that is defined inside another function, it is called a nested function. So let's say we have a function. The example we use is add num, right? Or let's say add numbers AB, and we want to define another function here, and let's say def product. And we'll say the product here is let's supply an argument x, and what we want to do now is to return a plus b times x. Let's do something like that. This doesn't even make any sense, but let's do it. Or we can actually do the one that we did, the area of I think it was the area of a trapezoid, the one that has the formula 2 plus base times side or something like that. That was the area of a trapezoid? No, I think it was the perimeter of a parallelogram that has that formula. Let's use that one to explain this better. So we did that for higher order function, and we said that I think that would be a better example. The perimeter of a parallelogram is equal to 2 times length plus breadth, something like that. It's supposed to be 2 times side plus base is still length plus breadth, anything you call it. Okay, that's the perimeter of it. We want to use this as an example. So let's say def sum num, and we put a b here, and we'll have an inner function that will calculate the perimeter of the parallelogram. And let's say here we'll have like that, and we'll say we'll supply the argument let's say this does not take any argument, and here we'll just return. So for this, we'll have to put the the inner function. So they have an outer function and an inner function here. So say the inner function is the perimeter of a parallelogram, and this will just return 2 times a plus b, and this will return the perimeter of a parallelogram here. So do you understand what I just did? This is a different way I've done this. This will first of all calculate the sum of a and b and multiply it by 2 when it gets to the inner function and return the outer function. So when I call this function now, and nested function and closure, I don't know how to explain this without explaining them together. So I'll call this, let's say x will be equal to sum num 2 and 3. This will add 2 plus 3. Or let's use one that we used there to see the value that we'll get from this perimeter. So we use the perimeter that has 5 and 7 as the base, and we return 24. Let's try that. I'm doubting this will do that, but let's say 5, 7. That's what we want here. We've created a function on the fly called x, and x has returned the inner function. This is returning a function, and now we want to say print x, and we'll supply. We don't need to supply anything here because now this is empty. It does not take any parameter. So just return it multiplying by 2. I don't think this is the best example, but let's see. Yeah, we'll not put this. We'll just print x and see, and we'll get the 24 printed out. Now you see what happened here. We put an outer function, which is the sum of 2 values, just the way we did higher order function, but now we decided to use the nested function method to do it. And then we use the inner function to be the perimeter of the parallelogram that we want to define. But we don't want to, we want it to take the parameters from this outer function. That's the outer function is the only thing people know or we see. The inner function is encapsulated. When we call the outer function, we supply 2 arguments to them, a and b, which is the value of the side and base. And when we call this, let's say we store it in a variable, that variable is now a function because this is returning an inner function, which means that it's going to take the number of arguments that the inner function wants me to take. So when I'm returning this value of I'm returning the value, when I return the inner function, I'm not supposed to return this with the parentheses here. Okay, so when I come here to print x, I can put the parentheses here. So that's why I got that error there. And so when I put the parentheses now, it prints 24 because I took it out from what is returning. Is it a little bit more understandable?
Yes. That means the outer function is called and it prints the inner function.
Yes.
First.
Yeah.
Okay. Okay. Thank you.
So every time you call the outer function, it returns a function for you. So you always call the outer function, save it in a variable, and then you call that variable as a function, which is now the inner function.
Okay.
Yeah. All right, everyone. If there's no question, we'll try to make the recording available within 48 hours. And see you next week. Try to practice over and over again because the topics now are highly connected. If you don't understand one, it will affect your understanding in the next topics. All right. So have a wonderful weekend, and you will get your grades by Monday for all the outstanding grades. Sometimes we don't want to release grades, especially when we have a student in the class who maybe for extenuating circumstance had to get an extension to submit the assignment late. So we don't release the assignments and people begin to, it's like a disservice to the people who sat down to get the work done, and then they begin to know what the answer is and what is correct and not correct. And so by Monday, by the end of Monday, next week you should get all of your outstanding grades released, and you know where you are currently.
Thank you.
All right. Thank you, ma'am.
All right. So have a wonderful weekend, everyone, and see you next week.
You too.
Okay.